Welcome to June 6th LeetCode Challenge, longest consecutive sequence. Given a unsorted array of integers nums, return the length of the longest consecutive element sequence. You must write an algorithm that runs in big O of n times. So that's essentially return the length of the longest consecutive elements in the sequence that's unsorted. So what that means is that we want to sort. Intuitively, we want to think about this. We want to sort the list first. And we also want to put it in a set so that there's no replicate elements in the array. So there's many ways of solving this, but there's using the brute force approach where we could the sequence starts at any number nums, so we could exhaust the entire array by searching the space by building the sequence as long as the sequence as possible for every possible number. It's not a very clever thing to do, but it's one of the options. And then we could build upon that as well by sorting the array first. So we can iterate through each element of it in ascending order, and that will be easy to find the sequence in consecutive number. To do so, we can just sort the array. So let's kind of use the brute force and the sorting approach and to build on that, and we're going to use what's called a hash set. So we're going to store, we're going to optimize our brute force solution and sorting solution a little bit better, just to improve our big O of n to be time complexity. So let's start off. So we're going to think of an algorithm that kind of makes it allow us to attempt to build a sequence from the numbers that are not part of our longer sequence. To accomplish this, we're gonna first have a number that would immediately precede the current number in a sequence. Yeah, as long as the number is needed, it will be part of the longer sequence. So let's start off with initializing our initializing our set here. So we have nums equals set nums. We're gonna put it in a set to remove any consecutive element. Remove any repetitive elements. Then we're gonna initialize results. So this is our longest sequence. Results to 0. Then I'm gonna do a for loop here. So for n in nums, if n minus 1 not in nums, then we're going to have a start variable that's going to equal to the n value. Start equals n. So while start in nums, start will be incremented by 1. And then results equal to max of results and start minus n. Then at the end of this, we want to return results. And let's see if this works. Seems to be working. Submit. Awesome, accepted. So let's see. Time complexity. Even though the algorithm looks like it's a quadratic, due to the while loop within the for loop right here, the while loop within the for loop. If you look a bit closer, we see that it's actually running in linear time, because we have these nested loops being actually a big O of n plus n time, which is equal to big O of n times in terms of time complexity. So all the other constant other computations occur at constant time, so we could rule out that overall runtime is linear. So this while loop right here, if I could just be a bit more detail here. So the while loop only runs in n iterations through the entire runtime of the searching of the algorithm. So that's why we have it to be big O of n times. So in terms of space complexity, we also have big O of n for space complexity. And that's pretty much it. Have a nice day.